Right, so question number 13. So we have following procedure was used to determine the sulfur content in a coal sample. Okay. So sulfur was burned in oxygen gas and SO2 is formed. Then sulfur with oxygen forms SO2 gas. So yeah, that is okay then. And then the foam gas collected in a solution of H2O2. So H2O2 can be either considered as oxidizing agent or reducing agent. And this solution was then titrated with NaOH. So you need to automatically quickly guess what is happening here. So if NaOH is titrated, so when you send SO2 to H2O2, you should understand there is a reaction that is forming acid, because the acid should react with NaOH. The volume of NaOH required to reach was given. The percentage of sulfur in the coal sample is. Okay, so we will use the board for this one, so which will be easy for us. Okay, so the idea is there is sulfur in the coal sample. So this is a coal sample. The weight is given as 1.6, I guess. Yeah, this is 1.6 grams, and SO2 is formed. So SO2 is sending to H2O2. So what is actually happening here is SO2 will be converting to SO42 minus, which is our oxidation, and H2O2 will be converting to H2O, which is our reduction. Okay, this is the oxidation and reduction. So when this oxidation and reduction happens, there is an acid that is formed and it reacts with NaOH. So it costs like 0.1 m NaOH, 20 cubic centimeter. So we don't know the acid, so we have to check what is this acid first, and then we have to calculate the percentage of sulfur in this coal sample. Okay, so we will do the calculation very quickly. So first we have to balance oxidation and reduction and see whether what is forming actually. So sulfur is 1, sulfur is 1 here, so oxygen is 2. So I'm going to put here 2H2O, and there will be 4H plus that is forming here. Okay, and here I will going to put 2 electrons to balance the charges. So 2 minus 2 minus 4 plus, it is neutral, done. H2, 2H2 is done. So there is 2 oxygen here. So there is 1 oxygen. So in fact, to put oxygen, we put water. So in fact, here it should be 2 water. So to balance the hydrogen, so I am going to put 2H plus here. Okay, this is 2H plus. Then to balance the number of electrons, so I have to put 2 electrons here. So this is balance. So you can add these two. So when you add these two, you will see this H2O is going to cancel out, and there will be this H plus cancelling out. There will be 2H plus here. Electrons are gone. So we have the SO2 and H2O2 reaction giving SO42 minus and 2H plus. So what is this? This is H2SO4, which is our acid. And this acid is going to react here to forming Na2SO4 and water. Right? So you have to balance this one. So I'm going to put 2 here and 2 here. Okay. Then what you can do, so you have all the reaction. So you can calculate the number of moles of NaOH, in which then you can calculate the number of moles of H2SO4, which is the number of moles of this one, and which is the number of moles of SO2. And if you know the number of moles of SO2, it will be equal to the number of moles of sulfur. Okay, so here this will be 0.1 m times 20 into 10 to the power minus 3. So here there will be 2 into 10 to the power minus 3 moles of NaOH. Then the stoichiometry is 2:1. So the number of moles of H2SO4 is 1 into 10 to the power minus 3 moles. Okay. So if this is 1 into 10 to the power minus 3, this is 1 into 10 to the power minus 3. So this is also 1 into 10 to the minus 3. So if this is 1 into 10 to the power minus 3, this is also 1 into 10 to the power minus 3. So here in the coal sample, we have 1 into 10 to the power minus 3 moles of sulfur, and its weight sulfur is 32. So this should be 32 into 10 to the power minus 3 grams. Okay. So the weight that is used is 1.6. So this will be 0.032 grams over 1.6 into 100. So in fact, this is 3.2 over 1.6, it is 2%. So in the coal sample, we have 2% of sulfur. Okay. So you can imagine how this calculation goes. First thing that you need to identify the acid that is formed. This is H2SO4. Then you need to calculate the number of moles of NaOH, and you have to go back. Okay, but don't forget, if you think this one as separately like H plus, you are going to end up in a wrong place. For an example, if you think this as 2H plus is to SO2 is 2:1 ratio, it is wrong. Why? Because H2SO4 acid itself has 2H plus. So when you combine these two, it has only 1 mole of H2SO4. That is why the stoichiometry is same. Otherwise, if you think this is 2:1, then you are wrong. That's the point. Okay, don't forget. When you combine these two, there is only one acid that is formed. That is this one, H2SO4. Right. Right, so I'll share the screen again. So we have the answer that is 2%. Okay. This is another typical question.